Hello guys, welcome to Self-Help Maths Academy. So today we are going to discuss about the limit and we will see what is the limits concept is and through the help of example. So today's discussion will be about limits. Now for that what we do is let's understand the behavior of function. Say y is equal to x square minus 1 divided by x minus 1, x square minus 1 or x minus 1 at x equal to 1. I mean, in the neighborhood of 1, we will understand the behavior of this function at the left neighborhood and the right neighborhood. Let's see. How do we do this? For example, I have 1. So at the left hand side of 1, if I consider it may be like say 0.5, 0.8, 0.9, which is very near to this one value. And on the right hand side of this, we can take say 1.1, 1.2, 1.5, 1.8, up to say very close to 2. So this way we will understand the behavior of this particular function at the neighborhood of 1 from both left as well as the right. Now for this, let me take the okay. Let's see. Let's understand. If I take here x and let us take y. If x is equal to, if I consider say 0.5, this function will be 0.5 the whole square minus 1 divided by 0.5 minus 1. Now 0.5 the whole square will be 0.25 minus 1 divided by, this is negative 0.5. So this will be minus 7.5 divided by minus 0.5. And here this negative will cancel. If you just take this value, this will be 1.5. So you understand, by substituting the value of x is equal to 1.5, I've got the value of y as 1.5. Similarly, if I substitute the value of 0.8 in this particular equation, then I'll get here 1.8. And then if I substitute say 0.9, then the value will be 1.9. And if I substitute say 0.99, then the value of this function will be 1.99. So as you can see, as I'm coming very close to the value 1, this value will be approaching towards 2. Okay, so as x is getting closer and closer to 1, y value will be getting closer and closer to 2. That is the understanding what we are seeing in this function when it is approaching from left. Okay, so which we can also write as limit of the given function. If you take, that is x square minus 1 divided by x minus 1, as x is approaching from this negative sign up, indicate from left side, that is left hand side. This value is nearly approaching to the value 2. This is called as left hand limit. This is called left hand limit. Similarly, we will see now what will happen when we will see the same result from the right hand side. So what will be the change with the given function? Let's see, I take the value x and y from the right hand side. So let me take the value as 1.5 to the given function. So here it will be 1.5 the whole square, y will be equal to minus 1 divided by 1.5 minus 1. So this is 2.5 0.25 minus 1 divided by 0.5. So this is equal to 1.25 divided by 0.5, which is approximately 2.5. Now you can see for x is equal to 1.5, I've got the value as 2.5. And similarly, if I take, say, x is equal to 1.2, yeah, 1.2, then this is 2.2. Similarly, you can do the calculation. If I put 1.1, the value will be, say, 2.1. So 1.001, if I consider, it is 2.001. As in this case also, you can observe, as I'm approaching very near to 1, this value is also approaching to 2. So here from right hand side, as x approaches to 1, your y approaches to 2. Okay. So this is called the right hand limit. This is called the right hand limit. Yeah. And also we can write this as limit of same function x square minus 1 divided by x minus 1 as x is approaching to 1, but this plus sign indicates that it is from right hand side. This is equal to 2. So this is our right hand side limit. Now if you see, the left hand and the right hand limit are equal in this case. That is RHL, left hand limit, right hand limit, and left hand limit. Both are equal, which is equal to 2. Okay, in this particular example. Then in general, we say that this limit as x approaches to 1 is 2. So when left hand limit and right hand limits are equal, then in general, we say that this particular general limit, that is limit of x square minus 1 divided by x minus 1 as x is approaching to 1 is equal to 2. So in general, the the constant left limit as x tends to x naught from the left is called left hand limit. Usually we write this as limit of f of x as x is tending to x naught. This on the head you can see negative sign. This will denote the left hand limit. Usually we write it as L, the left hand limit. For right hand limit, limit of f of x as x is tending to x naught from right hand is equal to LR. Okay. So now actually we'll come to the definition. This is the background understanding of the limit. Now we will come to the actual understanding. So what the definition says. So we say that a limit of a function, say y is equal to f of x, as x approaches to x naught, is said to exist when, first condition, if both LHL, the left hand limit, and RHL, that is right hand limit, should exist. So these two conditions are important, that is left hand limit should exist and the right hand side limit should exist. Second thing is both should be equal. The left hand side limit should be equal to right hand side limit. If these conditions are satisfied, then we say that the given function is having a limit at a described point. So now let's see quickly what are the properties of the limit. Basic properties of a limit. How do we see the properties? Okay, so the number one is, if I have the limit of a given function, say f of x plus or minus g of x, as x is tending to x naught, this will be equal to, limit of the function, if you have this way, the addition or subtraction, you can write it as limit of f of x as x is tending to x naught plus or minus limit of g of x as x is tending to x naught. So this is our first property. And the second property says, if I have limit of as x is tending to x naught, say k into f of x. You have got any constant and then a given function. So we can write it as k into limit of f of x as x is tending to x naught. So where k is any constant, you can take k is constant. Okay. And then the third property says that if you have limit of f of x into g of x as x is tending to x naught, we can write this as limit of f of x as x is tending to x naught into limit of g of x as x is tending to x naught. And the fourth property says limit of f of x divided by g of x as x is tending to x naught, if this will be equal to limit of f of x as x approaches to x naught divided by limit of g of x as x is approaching to x naught. Okay. And limit of constant, if you have, which will be always constant, limit of k as x is tending to x naught will be k, where k is any constant. These are some properties which we are using actually in evaluating the limits. Now let's see, we will understand the evaluating the limits of the polynomial. How do we do it? For the polynomials, if you have polynomials in particularly, say f of x is a given function which is a polynomial, and then in this case, limit of the given function f of x where x is tending to say a, this will be simply f of a. So wherever x is there, I'm going to substitute that limit value when it is a polynomial function. So this is applicable for other non-polynomial functions, so as long as they are continuous functions. But for the polynomials, this is always applicable. So let's see, for example, okay, I want to understand what is limit of 4x plus 7 as x is approaches to 5. So clearly you can see now this particular function you can see it is like f plus g. Okay, so by using the property number 1, first I'll write this one as this way. Okay, so you can see here this is equal to limit of 4x as x is approaches to 5 plus limit of 7 as x is approaches to 5 by the property number 1. Now you can observe this particular function, it is like k. You can see here this one is like k into f, this function. So we can write it as k into limit of f of x by using the property again. So hence I'll write this as 4 into limit x as x is tending to 5 plus, the fifth property says that limit of the constant as x tends to x naught will be the constant itself. So therefore this value is 7. Since here what we have here is This is your constant k. So hence, the final answer for this will be equal to, as we know, this is 4. Limit as x tends to 5, it takes the value 5 because we know that limit of a polynomial function is equal to, say, 4. Wherever x is there, put 5. So 4 into 5. And the limit of the constant as it is 7. The answer will be 20 plus 7, which is equal to 27. This is one way of doing it. I mean, like we have done in detail. But just if you use the polynomial function, as you are seeing, limit of f of x as x tends to a is just f of a. So if I choose to do this, then let us consider the example again. This is as x is tending to 5. It's a polynomial function of order 1. Now this will be equal to, wherever x is there, just put 5. This is 4 into 5 plus 7. Because this is free from x, nothing to be worried about. This is just 20 plus 7, which is equal to 27. So by using the properties, also you can solve this example, and by using the polynomial also you can solve this. Let's see another example. It says limit of x square minus 2x plus 7 as x is approaching to 4. So let's find this value. This is equal to, now I'm going to use the polynomial, that is, we know limit of f of x as x is approaching to a will be equal to f of a. So if you consider this as a polynomial, it is simply wherever x is there, just substitute the value. It is 4 square minus 2 into 4 plus 7. This is equal to 16 minus 8 plus 7. So this will be 23 minus 8. 23 minus 8. Then this will be 15. The answer is 15. Okay. So similarly, let me take another example. Say limit of sine square x plus tan x as x is tending to pi by 4. So this is again, I can write it as limit of sine square x as x is tending to pi by 4 plus limit of tan x as x is tending to pi by 4. So this one, wherever x is there, I'm going to substitute pi by 4. This sine square pi by 4 plus tan pi by 4. And we know sine pi by 4 is 1 by root 2, 1 over 2, 1 over root 2, the whole square here because it is square. And tan pi by 4 is 1. So therefore the answer is 1 over root 2 will be just 1 by 2. Square and square root will cancel. Plus 1. You take the LCM. This will be 3 by 2. The answer is 3 by 2. Okay. So likewise, you try these examples for yourself. Limit, say 8 minus x cube as x is tending to minus 2. Then say limit theta plus ln of theta as theta approaches to 1. So try these examples. And one more example, say limit square root of 2x plus 1 as x is approaches to 4. So try these examples and get back to me with the answers, guys. So with this, we conclude today's discussion, where we will get back to you with the next understanding of a limit with the next video. Till then, take care, guys. See you on the next video.